Hello guys, and welcome back to a brand new video. And in this video I'll be showing you guys my very own sort of library that I made in C++. Now I've currently been working on it for the past few days, but it is not a complete library. So far we have just about 165 lines of code, which doesn't really show the performance of the code, but it's just to tell you that there's 165 lines of code so far. Now, basically why I built this library was to make things easier whenever I want to make a console application. And so basically I created this header file, and that's technically a library which I'm going to use to create all my any console applications that I want to make. So for example, if I want to make a command line, I would be using the functions that I have over here. Now, there's no really classes over here. There's just a bunch of functions that you can use, and that's literally what this header file is. As you can see, we have things like this run application function, which allows us to pass in a name to our console application, and then we have a fill color, so we'll change the color of the console. And as you can see, we have different types of strings that defy different colors, and I'm using a little built-in library which allows us to change the color of the console's text color and the background color. And so I just created these little things to make it much easier, and that's what a library does. It integrates other modules and makes things easier for us personally. So like, it's called consolelib.h, which I would find very useful. So that is what inspired me to make this little library. I'll post a link to the GitHub in the description below, and I'm just going to be doing a showcase of this library and the different kind of things we can do. So first I'm going to be talking about the create default entity function in our console console application library. Now, as you can see, this function takes in 3 parameters. It takes in integers of size, it takes a string shape, it takes in an int x and an int y position. Currently, the x and y positions aren't working because what I'm trying to do in these little for loops is I'm trying to give a little bit of spaces, but with strings. I'm trying to iterate through this for loop, and at the same time I'm trying to create a little backslash n character for a new line for the y-axis, and then I'm trying to make an indented or spaced string, so an empty string that has a little space inside of it, in order to create that sort of like grid positioning using the x and y parameters that were given in the function. And basically this function, so far I've created 3 kinds of shapes or entity shape options, and the length is 3 in this array. It's a string array, and we have a pull type figure, and as you can see, these are all in capitals, showing it's like a library constant, different types of things we can do in the library. So in our library so far for our entity shape options, our default entities, we have a pull type figure, a square type figure, and a bracket type figure. Now, we have these little if statements that are going through and checking if we chose a valid entity that exists in this array, and that is taken through the shape parameter. So the reason why I'm just explaining the code, even though this is just like sort of like a showcase to you guys about this library that I'm making to make the creation of console applications much easier, is that I just want to show you guys like how this code works in a very basic overview. So like, we have this parameter called shape, and then it checks if the shape is a valid shape, so a part of this array, and then it will see if it's indexed by 0, which is pull type figure, and then it will execute the command. It will create a pull type entity, and at the same time, this little grid positioning system that I've created using these 2 for loops, it's not working so far, and so I'll be deprecating this and fixing it and rewriting this code so that the grid system created by the x and y parameters will actually work. So like, if we take a look at the console, so if I go in Microsoft Paint, And pretty much our console window is always going to be this little square window and be black and white. And what this grid positioning does is it just moves it from the origin. And in this case, the origin would be 0, 0, and that would be the top left. Because in computers, even though in mathematics the x and y axis, y would go up, x would go this way, in this case, x would be going... Actually, no, it's just y. So x is fine, so the x-axis is correct. It's just y is not very... So, sorry guys about my drawing. I'm drawing with a cursor. You might not be seeing this properly, so I'm just going to delete this. So, x is working fine. It increases, so it increments as we go more to the right. Okay, so I'm just showing you guys, just like over here, but only the y-axis is a bit different. So I'm drawing with my cursor, that's why it's a little bit very neat. So the y-axis, but for a computer, since the console starts from this position and then has this nice little rectangle window over here, the y position is going downwards and then incrementing, even though for x everything is fine. So that's just a little bit of... And essentially what we're doing is we're making a for loop. So like we're iterating through the amount of x specified and the amount of y specified, and then we're adding, for x we're adding a little string with some space inside, and then for y with one space inside, so an empty string with one space inside. And for y, what we're doing is we're just adding a \n character to the string. So we're just creating \n character, and then we're just printing that out, the amount of time specified by the for loops in our program. And the system's not working, so I'll be fixing it. That's literally what this is. And so essentially what we're doing is we're executing. So if the shape entity is equal to the second square type figure, we execute a function that creates square type figure. And then this is just the grid system that's not working currently. And then obviously the last one is bracket. And so we have a create bracket entity function working over here that takes in the parameter size. And the size is already one of the variables taken over here. So the size of the pool entity that we're creating. Essentially, these are three types of shapes or types of models that I've made using bare bones strings. So like this is not like a heavy game development library or whatever, because this is only meant for console applications. So we'll be utilizing strings. And then this is like create default entity, and it gives you the 3 default options where you're limited to like specifically how a pool type figure would look like. And so if we find this function earlier, we can see what kind of shape a pool type figure would execute. And essentially these are the 3 shapes that we're creating. So create bracket entity. So create square entity. Let's go to create pool type entity. So essentially create pool type entity is just it's an array initialized with a single pool. So the pool in your keyboard, and then we created a variable string mRadius, and then we're indexing e by 0, so the first variable, and then we're plus equal, so we're incrementing it by another pool. So that's how this little shape configuration works, and I'll be showing you guys how this actually creates a pool entity for us. And the larger the radius, the bigger the shape will be, and that is just that. So next off, same thing being applied over here. Same thing being applied over here, and then the last type of entity that we can create is a complex entity, which doesn't just take radius, but it takes in look. So now these specifiers can be anything, so I can make any kind of design that I want, but the same shape principle, so the same way it's going to draw the shape is the same, but now we can have any kind of string. So instead of being limited to the single bracket character, we can have anything that we want, and that's what the create complex entity is. Essentially the same way of drawing the shape to the console over here, drawing the entity to the console, but we just have a more we can just choose between whatever string character, whatever look we want for that entity. And that was void create default entity. And next off we have void create custom entity, which passes the same parameters as create complex entity, except it also passes in look. So essentially what it does is it adds an extra parameter called string color, and Now we can change the color of the console again, and then also now we can change the color of the entity itself. So like these guys, they have to stay in the same color, but then over here we add a new color, and we can make the entity look anything that we want it to look like by passing in a string. So yeah, that was just a little overview of our console library so far for making console applications, and we have a long way to go. I'm planning to like do a lot here, so soon in the future continue the development of this library. And for me it's library, you can consider it whatever you want, but it just makes something as simple as console applications, which might not get very simple when you're making a command line interface, but you know what I mean. Like it you should create a library for yourself. Like try experimenting this. This is the whole reason why I want to showcase this, not to like show everyone, oh, I can make a library for like even something in the console. Well, it's because whatever you need help with, so like in case you want to build your own command line, find a way to make that easier, so by writing code. So before you go into a big project, write some code to make that to make the development in that project much easier. So you need to set up a little, you don't just set up a nice little workspace for yourself in order to create a project, but you would also have to create some sort of library. You don't need to, no, that would be a much extra step since you're writing all this code, and then you would have to get into the project itself, which is over here. But what you actually need to do is like, but what this allows you to do is essentially is it allows you to expand your knowledge, so you're like you're coding more than you would usually do. So like instead of just making that project, you're learning how to make building projects itself easier by writing even more code. So for example, last time I wrote my own debugger in Python when I was creating a Python application. I wanted something to like debug simple things because I was always getting this little indent error where I would have, instead of 4 spaces as a tab, I would have something else. So then I made this little debugger that would find the exact line where the thing was, and it was very simple. It was an 80 line of code. It was a debugger for Python made in absolutely 80 lines of code or 90 lines of code. And yeah, you can do something simple like that. Like it doesn't have to be so official. Like even this is a library just made for the console. Just be as creative as you want, but you know, writing code to making a project easier is essentially what I'm trying to show you guys in this video. Hope you guys liked this video and enjoyed, and stay in tune. Stay in tune for another video. We'll be updating the Learn C++ for Absolute Beginners tutorial, and I hope that even if you're a beginner watching this and you're wondering what is all this code, well, it's just for a showcase. So anyone can watch this video even if not experienced, but like it's just showing you that once you get to like some other level, or you're at this level where you know some basic syntax, you should start like experimenting and build your own libraries to make stuff easier for yourself. Even if you're not going to sell it to someone, like no one thinks that they might need a console library. They might think they just want a game library with actual like graphics and all that stuff. Well, and last but not least, here is a project demo. So I'm just going to be running the file that which I created an entity in, and then like using the library. So I've included that header file in a run file, so like main.cpp, and essentially that's just testing out the library that I've made. So I'm just going to open up the folder. It's inside of a folder called 2D geometry. Open it up, click on source, and then inside of here, render, we have our console lib over here. And then if you go back, here's our run file, and essentially if I edit this with Notepad, just to show you guys the code, should just open, oh, yeah, over here, open with, and then just hit Notepad. Essentially, the output should work. So we're running the run application, and we're naming it my application, so that's the console application, and we're giving the application a background color of the color of green, so the text will be green, any shapes will be green, and with a background of black. And that's what the constant for underscore green underscore bg underscore black does. That's the one of the color types. And then we have create default entity. We said 4, so that's the radius. This is the type of entity we want, a square type figure with an x and y position of 2 and 2. And then we've got create custom entity with a radius of 4. And then our very own type of figure, so like our very own type of string. And basically it's going to draw that out in the same way. So essentially this character will be drawn out with a radius of 4. And then with using the create custom entity, because this is using a square type figure which has to look like that, but this one can be dynamic. I can change it anytime I want to look whatever I want. And lastly, we're giving it a color of 4 yellow BG green, whereas here you cannot change that color. So essentially what this do is it will be able to override the color of the window. So instead of seeing green BG black, we should be able to see 4 yellow BG green. And just to keep the colors the same, we'll be changing the strings to be the same. Alright, so let's test out our output and let's see if it looks like a square type figure. Just to tell you guys how a square type, let's change this to some asterisks. Alright, so a square type figure would look like this, and then with a radius of 4 it would just give us something it would give us a larger size than the normal char itself, the normal string itself. Alright, let's run this code, and essentially all these functions are coming from our consolelib.h header file. And then we can run our exe over here. And if you saw that, we just got this nice little thing over here. So if I run as administrator, we'll stick with running it in VS Code because whenever you run the application, it will automatically close after 3 seconds of execution. Well, however long your application is. So essentially, we should see our title, my application, and we should see that our shape is 4 green BG black, and then right after that we've got our nice little asterisk shape over here. That's how triple asterisk would look like with a radius of 4. If I did a single, you should see just a single character with a radius of 4, and it will look quite different. And of course, for some reason, the X and Y positions are not changing the grid through spaces and new lines, but they're actually being the sort of size manipulators. So this would be instead of doing that, it's becoming the width and the height, while the radius is how far it is from the center. So we should change the name of the X and Y variable to width and height, because that's what this is doing. And then 4 is just enlarging this 2x2 array. And then after that, we would just, next time, we would give in an X and Y position as int X and int Y. So you guys can play around with this. The GitHub link will be in the description, as I said earlier, and hope you guys